Hello 7th graders and welcome back. This is going to be our last video before we take our test on Friday, and this video is just kind of wrapping it all up, so we're putting it all together. So we're titling it Proportional Relationships, Putting It All Together. Our objective for today is I will be able to make connections between a proportional word problem, ratio table, graph, mathematical process, which is the same thing as equations, and model picture. Okay, so let's keep going. So lately, just like our objective said, we've been talking about word problems, ratio tables, graphs, and equations. So we're going to see how they all have a relationship together and they all connect. All right, so we're going to use this one word problem to connect all of the aspects together. So our word problem for today is if Mark uses 3 3/4 tablespoons of coffee to make 10 cups of coffee, how much would he need to make just 1 cup of coffee? Okay, so this mathematical process, we're going to use this for is we're going to say, well, let's solve it like we would with a proportion. So proportion is how we're going to solve it first. So if Mark uses 3 3/4 tablespoons of coffee to make 10 cups of coffee, how much, remember how much is what we're trying to figure out, how much would he need to make 1 cup? Okay, so 3 3/4 tablespoons of coffee to make 10 cups of coffee is equal to, we don't know how many tablespoons yet to make just 1 cup. Now remember, we're going to cross multiply to figure out this unit rate. Okay, so 3 3/4 times 1 was 3 3/4 is equal to, because we're done with that side, 10 times x. Okay, so what we're going to do here now, remember that we're isolating this variable, so we're dividing 10 by both sides to get that x all by itself. So that's going to leave us with x equals, now we got to figure out what 3 3/4 divided by 10 is. So I'm going to do this over here just because, it's going to get a little messy. It's a little bit more work since it's a fraction. So remember, when we divide fractions, or a mixed number, we need to make it into an improper fraction. So to make this in an improper fraction, the 4 is still going to be our denominator. 3 times 4 is 12, plus 5 is 15, and we are dividing 10 over 1, or just 10. Okay, and now when we divide a fraction, we need to keep, change, flip. So 15 divided by 4, or over 4, times 1 over 10. So now we multiply straight across. 15 times 1 is 15. 4 times 10 is 40. Okay, now we have 15 over 40. We can reduce that by dividing by 5, both the numerator and the denominator by 5. 15 divided by 5 is 3, and 40 divided by 5 is 8. So, with that being said, we have 3/8. So we have 3/8 tablespoon per cup of coffee, per cup. Okay, so we're going to remember that. So make sure you're writing all this down so we can refer back to it for each representation that we talk about today. Okay, so let's talk about the picture. Now, the picture is something that we did a lot of in 6th grade, not so much in 7th grade, but we can think about it the same. If you're stuck, you can always go back to drawing a picture. It's a great place to start. So if we use 3 3/4 tablespoons of coffee to make 10 cups, how much would he need to make 1 cup? Okay, so if we have 3 whole tablespoons, and we're just going to use bars, that's how I like to draw it. And we're going to split this last one into 4s because we have 4 in our denominator. And we used 3 of them, so we are going to just draw this line right here. This is how much it takes to make 10 cups of coffee. Okay, and we can divide these into 4s if you want to. And we know that we used 3 3/4. Okay, we're asking ourselves, well, if we want to know how much just 1 cup of coffee is, what do we need to do? Well, we need to divide this 10 times. So we know that we're going to divide this 10 times. So 3 3/4 divided by 10. That's what we just did. It's the same math. So that equals to 3/8. So we know that there's 3/8 tablespoon per cup. Sometimes drawing the picture just makes it, you can visualize it a little bit easier. Okay, so now let's take a look at the ratio table. Okay, so for the ratio table, first of all, we need to decide how we're going to label it. All right, so remember that x is our independent variable. And our independent variable is, it doesn't depend on anything. Okay, sometimes it's easier to figure out the dependent variable or the y variable first because the y depends on what the independent variable does. So in this case, if Mark uses 3 3/4 tablespoons of coffee to make 10 cups, this y value depends on how many cups of coffee it is. So the independent variable is cups of coffee, okay, and the dependent is tablespoons of coffee mix. Okay, so we're just going to fill out this. We're going to start with what we know. So we know that for every 10 cups of coffee, that you need 3 3/4 tablespoon of coffee mix. Now we can just fill this in by simply counting backwards. 7, 6, 5, 4, 3, 2, and 1. I could have gone to 0. You could do another one to do 0 as well. Now we just said that the unit rate was 3/8. Okay, so 3/8. Now you can use the unit rate to keep adding, repeated addition, keep adding 3/8 to each one to fill out the graph. So 3/8 plus 3/8 is 6/8, which you can reduce to 3/4. Okay, plus another 3/8, which is 1 1/8, plus another 3/8, which is 1 4/8, which is the same thing as 1 1/2, and you can keep going. Okay, so now let's take a look at the equation. Remember that our equation has to be in the form of y equals kx, where k is equal to the constant proportionality. We did notes on this earlier too. You can refer back to your foldable. So y equals kx. So we know that y is equal to the constant of proportionality x. Right? So what's the constant of proportionality in this ratio table? Well, it's right here. Right? So y is equal to 3/8 x. So another way that you can figure out all these missing values is plug it in. 3/8 times 5. Right? So 5 times 3 is 15 over 8. 15 over 8, and then you could simplify it, and then you would get your answer. This one would be 1 7/8 after you do that. Okay, or you could do the repeating addition. You see how it's all connecting. All right, so the next and last thing that we're going to do is the graph. Okay, so the graph, so we just figured out that the equation is y equals 3/8 x. Okay, and if we went back to that table, we would know that our origin, it would go through origin, because if you don't make any coffee, you're not going to need any coffee to make it. So you don't need it, your origin. No, my pen's not working. But anyways, so to label the graph, it's the same thing that what we've been working on. So our x-axis is cups of coffee. Our y-axis is tablespoons of coffee. Okay, you want to go 1 through 10 to label it. So label your axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm sorry about how messy mine is, but you'll be able to see it a lot better when we go over some examples in class. And think back to the examples that we did yesterday in class 2 about graphing. So, tablespoons. How I would go and how I would label it is I would label it by either 1/8 or 1/4. Okay, so let's see if we go up by, so 8s isn't going to work on this graph because there's not going to be enough room to do all of these 8s that we're going to need. So I think that we should do it by 1/2. So each line here is going to be 1/2. So I'm going to skip 2 lines, that's going to be 1. Skip 2 more lines, that's 2. 2 more lines, that's 3. And 2 more lines, that's 4. Okay, so each of these lines right here is 1/2. Okay, and we're just going to have to estimate a little bit. It's not going to be completely precise, but you'll see that it's going to make a straight line because it's a proportional graph. So our first point is 0, 0, because when you make 0 cups of coffee, you're not going to need any coffee mix. Okay, our first one, if you look on the graph in our unit rate, our constant of proportionality is 3/8. All right, so we go over 1 and up 3/8. Okay, 3/8 is almost half, so we'll point it right here. Okay, and then we'll skip to 10, and then we know that it's 3 3/4 tablespoon. So 10, go up 3 3/4, which is about here. Okay, and then when you fill in all the rest of the points, it'll make a straight line all the way up because it's a proportionate relationship. You can see the constant of proportionality is right here because the x value is 1, and we can label that to x and y. The x value is 1, and the constant of proportionality we know is 3/8. Okay, so we find that each representation, each of them express the same information, but looks a little bit different. So we're going to talk more about this when you guys come back to class tomorrow, or maybe today if you're watching it in Seahawk time. Don't forget to write down those 2 questions over the video and come with the questions in class tomorrow. Thank you for actively listening, and I will see you later.